Welcome to the Alphalist podcast. I am your host, Toby. Alphalist is a closed community with over 600 CTOs who share their knowledge and experience in a Slack space and at events. With this podcast, we want to give our members and interested parties insights into the thoughts and ideas of top CTOs. If you're interested in becoming a member of the community, please visit alphalist.com to find out more on how to apply.
This podcast is proudly presented by Viadi. Viadi IT Consulting is looking for new employees. What can potential candidates expect? Innovative projects, appreciative colleagues who grew up with the internet just like you and share many nerdy memories. Today, we work in teams on the digital future of regional companies. For more information, visit viadee.de. That's viadee.de/en/career.
Welcome to the Alphalist podcast. I am your host, Toby, and today I am talking to Laura, and Laura is the CTO of Motional, and she will tell us exactly how to build a self-driving car today. Laura, is that correct? And maybe you can tell us a bit more about yourself and Motional.
Sounds great. I'll tell you as much as I can.
Okay, so what is Motional actually? Like just in a few sentences. I read that it's I think a joint venture. Like, how did that evolve? And when did you start there?
Yeah, so Motional is a joint venture, half owned by Aptiv, which is an automotive tech leader, and half owned by Hyundai Motor Group, which everyone knows is the leading OEM. And so, yeah, Motional started back from two startups, really, going way back. Nutonomy out of MIT and Automatica, which was a team out of CMU that were both purchased by first Delphi and then Aptiv, and combined and grown within Aptiv. And then in 2020 is when we formed the partnership with Hyundai Motor Group and created the joint venture, which became Motional. And I joined Aptiv before the joint venture in 2019. So it was just a little less than a year before we formed the joint venture.
And I guess you studied at MIT and so on. Can you tell us a bit more about your personal journey as a nerd? Like, when did you start? How did you get into computing? What is your story there?
Yeah, absolutely. I was always drawn to math and science, from a young age. It always sort of came natural to me. But I also always had an interest in people and kind of in psychology. And so I kind of, started my journey, wanting to study the two together. So that started in undergraduate. I went to Georgia Tech, where I discovered, this field of human system integration. How do you design an autonomous system that has to ultimately work with people, and that has its roots in the aerospace industry. So I focused in for my graduate studies at MIT in aeronautics and astronautics, where I went deeper into this humans and automation field, and then I launched from there into the aerospace and defense industry, working on projects for NASA, an autonomous flight manager, working on systems for defense applications, working with many different robots, and so on. And I saw the impact that autonomy could have on real people. We were fielding systems, with astronauts and in the military, and I saw that how you could kind of complement the capabilities that people have with autonomous systems and with AI. And so, as the autonomous vehicle industry really started taking off, I saw that there was an opportunity to now bridge, the capability that I was working on in the aerospace and defense world, and now bring it into our everyday lives, into the commercial space. And so that's ultimately what got me interested in autonomous vehicles. And my interest first started with the book that I wrote with Julie Shaw. and where we really were studying and looking at how we could bring some of the lessons learned over decades in aerospace and defense into commercial systems, commercial robotics. And as I was working on that book and thinking deeply about the topic is when I started the conversations to join Aptiv.
Wow. Wait. That was like really a lot. I mean, was there like that key moment in your childhood when you, I don't know, were building a Lego rocket or something where you said, okay, I'm going into this field, or what was it? What was there that key moment?
I can't say I had a singular moment like that. To be honest, I was always fascinated by space. That kind of drew my curiosity from a young age. And then, I was drawn to engineering. But it was really when I got into college where I started to see, the full breadth of, different fields that again kind of covered this, the spectrum from robotics to human psychology and kind of how to bring that together. So yeah, I can't say there was sort of a Lego moment, like you say, but I always was curious, about technology and again found it sort of natural and easy to work on. And so it was sort of a natural step for me.
I once had the MIT professor or former MIT professor Sebastian Schroon here as my guest, and he was like telling us a lot about the DARPA challenge. Did you also participate there?
No, I didn't. At the time, I was at Draper, and we did participate with the MIT team, but I wasn't directly involved.
Okay, but it was then like a natural path, also for Draper student to go towards that direction more, right?
Yes, absolutely. I was working on autonomous systems there, but more flying systems and space systems at the time. So, but yeah, there was a lot of collaboration and certainly, I kind of got interested, more due to sort of the crossover into the commercial space is what ultimately kind of drew me into autonomous vehicles.
Okay, and like your focus on human-centered engineering lets me guess that you're also quite positive on the future of human like working with machines. Is that correct? Or
yes, I think it's our responsibility in the tech community to design systems that work well with society. But I think there's a tremendous opportunity if we do it right for robotics, to help society, to help a surgeon, to have a more effective and accurate procedure, to reduce congestion by having optimal routing on our streets, and to give people back time by offloading, whether it's a menial task like vacuuming your apartment, or by driving your car for you so that you can catch up on the news or respond to some emails. So I think there's a real opportunity to help people, through robotic solutions, but it requires, a focus on how to design systems that will effectively embed themselves, side by side with people and interact in ways that are intuitive and supportive, rather than being sort of a tech-first solution that ultimately is hard for people to understand and collaborate with, and it doesn't necessarily solve the task in the right way that will help the people that depend on the robot.
Okay, and like in reality, how far are we from like self-driving really taking over and winning?
Yeah, it's a question I get asked a lot. I think we are in sort of a phase shift right now in the industry. For a long time, it was sort of a promise off in the distance, but now we're starting to see the first steps. So we're seeing, driverless vehicles on our streets. At Motional, we took our first step. We had a driverless milestone early last year, where we started testing a driverless system. We see others in the industry. So it's starting, but it's going to be a journey. It's not going to happen overnight. We're not going to suddenly see self-driving cars everywhere. But it's going to start, small and grow in one city, grow to another city, and scale, over the next decade.
But if I remember correctly, one strange guy once promised me that I'll be able to earn money with my car already this year or last year through like just renting it out to strangers. Like, what was wrong with that promise?
Yeah, so maybe I can ask you to reframe. You're talking about Uber, like by driving?
No, I'm talking about Tesla. I'm talking about Tesla.
By Tesla.
I think Elon once promised that, right?
Got it. I see. Yeah, I mean, I think the whole tech community has discovered that it's a harder problem to solve than people first anticipated, and that's fair, right? It's a new, huge technical challenge that has to bring together a lot of sensors, a lot of data, make real-time decisions, complex AI solutions, and and bring that all into a system that works and that can be validated to be safe without a backup, human, monitoring in real time and ready to take over. So, when you don't have a sort of a backup person there to take over, in case of a failure or some error, the stakes are much higher, and so therefore performance has to be higher. Your test procedures, are more rigorous. So it's I think again that the tech industry learned that it's a harder problem to solve than first anticipated, and now we're starting to see some of those big wins, some of those big moments where we're seeing driverless, true driverless systems, validated, tested, deployed for the first time.
I think like one approach to really come to perfection and to really get like the right training time would potentially be gamification, right? To make sure that the driver is still attending the road, you could, I don't know, build little games that keep him or her busy watching the street. Is that something that you considered once, or?
Yeah, so certainly for level 2 SAE, like level 2, level 3 type solutions, where you design the system in a way that still depends on the human operator as the human driver as the backup system. You do need to do things like that, like what you're describing, to keep people engaged and maintaining situation awareness so that they're able to step in when needed. We find that like there are many aerospace examples I cover in our book, or we cover, I should say, where pilots, because they were kept out of the loop, the control loop, they often lost situational awareness, and then there was some failure that happened, a sensor or something that went wrong, and the pilot wasn't able to regain situational awareness in time to help correct the situation and stabilize the aircraft. And the same is true in cars. If the driver isn't engaged in watching the road, able to see that moment when there's a construction zone that causes the lane to veer in a funny way, or some other anomaly, then you can't expect them to necessarily like have the time and the ability to step in. So you do need to have some way of keeping them in the loop and keeping them engaged throughout the drive. But at Motional, we're focused right now on level 4, SAE level 4, which does not depend on a human driver to be a backup. It's a fully independent, autonomous solution that doesn't rely on any human on board to watch over the system.
And what kind of sensors does it rely on then? Tesla, for example, ditched radar recently and purely relies on cameras. I think Sebastian also told me back then that it makes sense to purely rely on cameras. I think I read that you also use radar still. What else do you use and why?
Yeah, at Motional, we feel that, given today's technology, that, a full sensor suite is required. So you need to have 360-degree sensor coverage across multiple modalities in order to have the right level of redundancy to handle, not just sort of the normal situation, but moments where you might miss a detection in one sensor modality, but, be able to detect it in another sensor modality. The classic example is, the white sky guy in the white truck being confused. You don't see the truck because it looks a lot like the sky. Well, radar wouldn't miss that. And so, Motional, we have LiDAR, radar, and cameras in 360 degree coverage.
And your job as a CTO is designing the hardware, the software, everything. Where does your job start and where does it end?
Yeah, so I lead the engineering team that designs all of that. We have a really talented team that I'm privileged really to lead. And so, it covers hardware, which includes, integrating all the components with the vehicle. It includes, selecting and adapting all of the components, so the sensors, the compute, but also other hardware you might not think of, like the displays inside the car to interact with the passengers, and the remote vehicle assistance, the communication back to a command center. But we have a hardware team, we have a software team that builds all the core base software on the vehicle as well as off the vehicle, the infrastructure, the cloud, simulation. And then we have our autonomy team, which is the team who builds all of the perception and prediction and ultimately decision making on the vehicle. And of course, we have TPMs, technical program managers, who help facilitate and manage all of that work and make sure it comes together. So that full team reports into me, and I have the honor to lead them as we design the system.
Crazy. And how much is happening in the car? I mean, obviously, like all the sensor work, and there has to be like the whole classification and everything, like the live algorithm is running in the car. But like how much is like if you look at your general stack happening there, and how much is happening in the cloud somewhere? Like how heavy are the calculations in the cloud in comparison? How does it work?
Yeah, well, when you have a real-time system, like a car, you really have to worry about latency. And so, we can't depend too heavily on the cloud for the safety critical calculations. And so those happen on the car. You don't have time to wait to send data off board and get a result back. You have to usually respond and react very quickly. Most of the sort of core software happens on board. We do have remote customer assistance that happens over the cloud, and remote. We monitor the vehicles through remote vehicle assistance. And if the vehicles get stuck in a situation where they're unable to, let's say, plan a path around a new construction zone that popped up, or let's say a traffic light is out and need to engage with a traffic officer, those are moments where the remote vehicle assistance over the cloud is able to log in and help provide guidance to the onboard software.
So is then your goal in a way to build like one big taxi fleet at the end, or is it also, will you also like release the car to the public? Can I buy like one of those cars in the future? Just like side question.
Yeah, I mean, I think that's the direction that the industry will go eventually. But I think the first step will be robotaxi fleet, and that's where we're focused today. But the next phase, I think, for the industry is to optimize cost. So today, all the sensors I described are expensive, right? Having that full coverage, but prices are going to come down. We're going to find ways to optimize the system architecture and the software itself as well. And so eventually it will make its way onto consumer vehicles. But today, I think that the first step is to have robotaxi fleets as well as delivery. We also announced late last year that we have a new partnership with Uber Eats, where we are going to be doing autonomous delivery of meal kits.
Cool. Then jumping back to software, like what are the core components of your system, and what is under the hood? I mean, especially looking at the AI topics, is there like, are you just using TensorFlow, or is it? I mean, what is self-written? Like how how complex is that system actually?
Yeah, so we have perception, prediction, planning and controls, and then drive-by-wire, how we interface with with the vehicle itself, and so we use a lot of machine learning in our solutions, and that requires tremendous amount of training data, and also sophisticated design of our neural nets. So I probably won't get into the details of exactly how it's all constructed, but yeah, those are sort of the core parts of our system, and probably really any autonomous vehicle has very similar components.
I think like one thing to optimize is as well like building all those sensors into the cars, right? I mean, right now it's kind of attached to the cars on top. Will we find it like all included in future series of the cars, or?
Yeah, that's a great question, and this is one of the ways that our partnership with HMG, with Hyundai Motor Group, has been so helpful. We actually are, taking the Ioniq 5 as you see it, and embedding the sensors and all of the other components into the vehicle. So you still see them, but it's a deeper integration into the vehicle than you see in some other cases. But I think, yeah, we'll see in future generations there will be even more, integration from the start of a vehicle design into the vehicle. And so it might not be as noticeable. But I think, I don't know if you've seen our Ioniq 5 robotaxi design yet.
Yeah, seen it.
Yeah, but you can see the sensors are more, a lower profile and kind of more in line with the design of the overall vehicle than some other alternatives.
And like just looking once more at Tesla, you think it's realistic that the amount of sensors they are now building into a Tesla are able to reach level 4 then as well, or?
Yeah, I mean, I certainly can't speak on their behalf, but I think for our approach is that for today's sensor technology, today's AI capability, you do need multiple sensor modalities to get to level 4, to truly get to a place where you have the right level of redundancy, fault detection and handling, and so on. But can we do it all with computer vision someday? Maybe. I think it's an ambitious goal, and good things will come out of trying. But I think in the near term, it's probably unlikely.
Yeah, I'm just asking because it kind of makes sense, but kind of doesn't as well. I mean, it's a very complex topic, and I can imagine that like just with cameras, it's ambitious.
Yeah, there are different, I think, different things, different strengths of each of the sensor modalities, and so by combining them, you have a more robust overall solution that can handle, again, these situations like the truck that looks like the sky. And so, yeah, in order to have a very strong, reliable level 4 system, we think that's the path.
Okay, and those the models that you build, the prediction models that you build, are they kind of delivered with the cars, or is there like some sort of an over-the-air update that kind of releases a new model every once in a while, every week, every second week or something? How does that work?
Yeah. So yeah, definitely the software comes on the car, but we have a continuous development process. We're constantly developing, expanding the software, testing it, in simulation, on closed course, on public roads. So definitely a continuous development process. And when there are, updates that are ready to go into production, then we make that update. But yeah, it's a continuous process.
And is there any preparation of the whole data flow involved? I mean, obviously you also have to have a team that does labeling and stuff like that.
Yes.
Or is that already, can you buy such data sets, or how does that work?
Yeah, so absolutely. The data, the feedback loop is incredibly important to continue training, our machine learning algorithms. And so we have a strategy around this. We call it our continuous learning framework, where we are, continuing to mine the data that we collect on the roads to find, rare objects or objects that are hard for AVs to perform on. And we use those to, expand our training data set. As you mentioned, you want to make that feedback loop as fast and efficient as possible. So that includes the data labeling. So we have initiative, around that where we use offline perception to automate some of that. And then also, of course, getting once you have the data identified through mining, to find those rare scenarios, labeling, and getting it into to train the neural nets so that they're able to improve.
This podcast is proudly presented by Moss. Moss is the all-in-one solution for company expenses. With Moss, companies manage all expenses in one place from anywhere. The powerful Moss credit cards are ideal for high cloud costs. Moss offers card limits of up to €500,000 and payment terms of up to 60 days. This helps you to optimize your cash flow. Save time and money with Moss. Manage incoming invoices digitally and set your accounting on autopilot. All receipts are automatically pre-accounted. Your accounting data can be exported directly to Datev. This way, your month-end closing is done in just a few minutes. Additionally, you get 0.4% cashback on every payment. Stay on top of all expenses and use Moss free of charge for 2 months with the coupon code ALPHA. For more information, visit getmoss.com/alpha. getmoss.com/alpha.
And is there any way to already measure how effective against like typical scenarios such a model will be before you deploy it? I guess yes, right? Because it's kind of hard to release it to the public without ever really trying offline.
Yes, we have a whole metrics strategy as well. You're right. You want to test first offline. So we have simulation. We have a whole database of scenarios where either we haven't performed as well in the past or that are really challenging scenarios to really stress the system before you stress the software before you put it on the road. So we our developers test their solutions against that database. Then we also test, integrated releases, and then ultimately, we test on the road. And we look at metrics, across many dimensions. So the industry typically focuses on disengagement metrics, such as a collision preventing takeover. But that's really at the system level. When we talk about the software performance, we get much more granular into detailed subsystem metrics. So detection accuracy, looking for false alarms where we detect something that wasn't there. Which ultimately affects your driving performance, prediction accuracy. So we're measuring all of that when we test in simulation, when we test on the road, to understand kind of not just does it result in some type of disengagement event, but kind of how is the each part of the stack performing, because ultimately that's what adds up to a solid system. So we have a very robust way of tracking subsystem metrics.
And that sounds as if you would rather like release a new model every few months instead of like every week, right?
I can't say what frequency that will happen in the future. We haven't deployed our new robotaxi yet. We're working on building up to deployment, commercial driverless deployment in 2023. After that point is when we'll really figure out the frequency of updates that we are comfortable with. But yes, any kind of update needs to have some level of rigor behind making sure that it's validated and ready to go into an autonomous car. But exactly what frequency depends on, how much you can automate and how much, how you can kind of get efficiencies in that testing process.
Can you tell us a bit more about the NuPlan dataset? I think that's a dataset you're releasing, right?
Yes, absolutely. So, yeah, in 2019, we pioneered, the release of data for the AV industry to really improve, safety and innovate and motivate innovation, across the industry. And we did that with NuScenes, our first data set. Now we see many other people, having similar data sets out there, but yeah, Motional was really the first, and it's important to us to continue to do so. So NuPlan is the newest data set that that we're releasing, which is motion planning data set, to provide these sort of challenging, motion planning scenarios, and be able to ultimately measure performance against them. So kind of like a virtual driving test.
Okay. And are then like other players in the industry also using that data set, or are there also groups around that to improve those public data sets together, or how competitive is the industry? That's for me hard to see. I mean, I just know it from the outside and know that there are a few players out there who do it. I think wasn't that the guy who hacked the iPhone in the past, George Hotz? Isn't he developing also self-driving cars and a few others independent companies? How red is the ocean of self-driving?
Yeah. So yeah, certainly. So there are a couple of questions maybe embedded in there. So yeah, certainly I think we now do see a culture of data sharing and collaboration in the industry. It wasn't always that way. I think once we released this data set in 2019, we kind of saw that that new culture take off. So many others do release data sets, and we do see many others use our data set as a benchmark for their own internal algorithms. And also for in competitions and in academic publications and whatnot. But in terms of kind of the AV industry, certainly it's a very active space. But we've seen quite a bit of consolidation, over the last couple of years. I think there's been an acknowledgement, as we talked about earlier, that it's a harder problem than people first expected, and so it's going to require capital. It's you can't solve the problem quickly. You need to have the right investment to work through the technical challenges and ultimately develop, a commercial system. And so, we feel like we have that with our parent companies. We think you need at least $1 billion to play in the game. And so, and also, the collaboration with OEMs in order to integrate the components with the vehicle is also another problem that I think was more complex and important than was first realized. And so I think we're seeing a much smaller set of AV competitors that have those right partnerships in place and the capital that they need to get over the line of building a real commercially viable driverless system.
So only a very few teams will actually achieve level 4, right?
A commercially viable level 4. That's right. I think you see, there are many acquisitions that have happened, consolidations to take pieces and parts, from some of the smaller players. But I think in order to do it at scale and in a commercially viable way, it requires a larger effort.
Okay. Yeah, I'm curious to see when you really reach commercial level 4. You mentioned that it's 2023, right?
That's right.
You plan doing that. I wish you all the luck that it will actually happen. And I'm really looking forward to see self-driving cars finally. I mean, I guess in the US, it's maybe happening already every once in a while.
Yes.
Over here, it's kind of a bit boring still.
Yeah, still new.
So, one topic I just briefly wanted to tackle is it's kind of unusual to have, or still unusual, unfortunately unusual, to see a woman really spearheading in such a STEM-heavy field. I hope that was politically correct. How was there? like how many moments of I don't know, misinterpretation and strange moments in your career have been there where you thought, okay, this can't be, that's just too much?
Yeah, definitely. I think any woman in the tech field has had a fair share of those moments. So yeah, for me, it's my focus has on how to work through those is try to find people who you can work well with and avoid some of those. I mean, truthfully, I think the there are systemic problems, of unconscious bias, but the real roadblocks for me haven't been too frequent. So I've been able to kind of avoid some of those situations or find champions and ways to work around. But then certainly I think there's the underlying sort of unconscious bias that is, sort of always there and impacts things in ways that you don't even always realize until much later after the fact.
But I guess you seem like to really master it well. Like just from my perspective, doesn't seem to bother you a lot, right?
Yeah, well, my strategy has always been to focus on results and not let those distractions become a focus for me. So when it's a good thing about working in the tech space. If you can build something and deploy something and make a difference, that speaks volumes, and it's sort of hard to overlook, even if you have an unconscious bias or you're sort of less less inclined to work with the opposite gender. So yeah, I focused on results and making an impact, trying to match my passion and my strengths with areas, projects, domains, use cases where I see an opportunity for impact, and then just deliver over and over and over again. And again, that pays off. And the noise, I think of it as the noise, that unconscious bias, those distractions, those fade away. And the signal that stands out from that noise is the accomplishments. And so, yeah, it's not that it doesn't bring me down sometimes or get in the way or feel frustrating. It does, but yeah, by focusing on accomplishments, focusing on results, focusing on impact, it's personally very fulfilling to, continue to, make an impact, make a difference, deliver systems that are game changing. That's what motivates me, and that's ultimately what I think, gets me my next position, my next role, my next opportunity, because that speaks for itself.
Okay, that was yeah, really. I can imagine that it's sometimes hard, but
Yeah.
like especially in that field, it's kind of also really maybe a bit different than like as you would work in classical automotive or something, right? It's like kind of so new field that it's maybe also there's like a certain understanding of how diversity should be these days, and how much results matter instead of the gender, right?
That's absolutely true. That's a really good point. In a more traditional industry, yeah, I think the biases and the challenges are more ingrained. But this is a new industry, young talent, innovative, fast moving, and so there's an element of embracing whatever it takes to get there. And so a part of that is diversity. We need diverse ideas. We need people thinking outside the box. That's the only way to get to the solution. And at Motional, we really embrace that. I feel so supported in this role in this company with these parent companies. One of the first things we did when we formed the joint venture was to stand up a diversity, equity, and inclusion initiative. And so really there's a corporate support for that, and it covers everything from hiring practices to training, culture, how teams work together. So it's something where there's commitment all the way from the top, and real support. And I think you're right. In this industry, there's no other way. We have to embrace it because we have to come up with the best ideas, and we need all the brightest minds together to come up with those ideas to solve this, challenge of our lifetime.
Maybe one or a few concrete tips from someone who lives and breathes machine learning and AI. I mean, it's kind of a very complex challenge already. If you just own the software to bring an algorithm live, like really from like end to end, right? Like a lot of things happening these days, like purely in IPython notebooks and let's say the laboratory. Do you have like a few tips you can give on how to actually master machine learning and AI best? I know that's like a quite generic question, but like just a few ideas of where to start and maybe what to avoid.
Yeah, a couple of ideas, a couple of thoughts. One is the data itself is more important than probably people realize when starting off in AI. We invest, our ML leaders invest a lot of time and energy into thinking about how to cultivate the right data sets, how to annotate and label data in a way that will produce the right results. And so there's a big element of data, to creating a true, ML solution. Another thought is, especially for those interested in a system like ours, a real-time, complex safety critical system. There's also, foundational software that this sits on top of. And so, the sensor pipeline, getting data from the sensors, latency, how fast you can close the loop between data and decision is incredibly important. And you can have the best algorithm, but if it doesn't function well, with these other, more practical kind of or traditional kinds of software problems, then it won't work. And so there's an element of you have to have a really strong, robust software infrastructure that your AI solutions fit within. And so that means optimizing your ML approach in a way that will efficiently work with the data that you have. We've innovated a lot in this space. Our team at Motional, with point pillars and point painting, looking at how do you use LiDAR data efficiently. Really thinking about kind of that, not just a AI solution that works well in the cloud, but one that can work well on an embedded system with high throughput data that in a way that can lead to very fast decision making.
Okay. And then like a few more like maybe productivity hacks from your end. Like how do you master your day? What is there like a recent discovery you made? Like something that makes you way more productive and makes you efficient as a CTO?
Oh, that's a good question. Yeah, I'm very strategic with my time. I recognize that my time is, one of my biggest assets, and making sure I'm using it properly is important. So I try to balance, a few key things. One is, of course, having one-on-ones to coach and mentor the engineering leaders within Motional, and to hear what their problems are and to help them work through them and really kind of, work through things together. Another is, looking at schedules and roadmaps, and how are we going to meet the milestones we have, and what did we learn last week, and how are we going to use that to adapt and change what we're doing this week, and really kind of refining that kind of tactical, and it's not just tactical, also the strategic part of the roadmap. Third is technical deep dives. So what's the technical approach that we're using for a particular problem? What are we struggling with? What isn't working well, on the car, and how are we approaching solving that problem? What new approach are we going to bring in? So there's sort of those three dimensions, like the people part, kind of the schedule tied with the business part, and then the technical part. So I try to, make sure I have time to cover, all three dimensions. But then, it's also important for me to have a little bit of time where I clear time in my schedule to work on things myself. Projects, whether that's, preparing for a meeting or putting together slides to communicate, our progress to our board members, or, thinking through an upcoming, newsletter I want to release to our engineering team. So yeah, that's something that was sort of, I previously was, I fell into the trap sometimes of allowing my schedule to get consumed by meetings that cover these three dimensions. Can kind of, easily consume every second in the day. But I've now strategically tried to carve out time where I can have quiet time with that. That's not a meeting, that I can do some heads down work, and also step back and do some thinking. Sometimes that means, take a walk around the block and clear my head, and, try to disconnect a bit so that I can come up with a more creative solution to a problem.
Yeah, the world of notifications is kind of harmful, right?
Yes.
Like I also wear an Apple Watch, and whenever you don't turn off many of them, you get bombarded throughout the day, right?
Yes. I do limit how much, I allow myself to get kind of drawn into the instant messaging world, whatever, application folks use. I do when I'm sitting at my desk, and if I'm not in a meeting, I will monitor, but I also have moments where I turn it off and I walk away and I clear my head and think through things, and don't allow myself to get distracted by those, urgent but not important matters.
Okay. I still have a little surprise for you. So last year for my birthday, Sebastian Thrun actually gave me one of the early DARPA prototype cars that were participating in the challenge. And it has a hidden Easter egg in it. If you connect your laptop and SSH into the car, and type the command time machine and give it a year, then it will actually let us travel back in time. And we're now using it. Let's imagine we're now using it and travel back to the year 2005 when you started working as a cognitive engineer at the Draper Laboratory. And you now have the chance to quickly observe yourself working there in the laboratory, and to whisper something into young Laura's ears. What would it be?
Wow, quite a visual. Yeah, so I guess, going back to that moment when I was just starting out, it was hard to really imagine where my career would go. But I think, if I could talk to myself in that one moment, it would be that, the sort of message I would give myself is that to keep going after hard challenges that excite you. Follow your passion, and don't let kind of fear or feeling overwhelmed by a challenge hold you back. Just go for it, and that you'll be capable of more than you expect. And when you follow something you're passionate about, it leads to a good place. Always, even if it's not quite the place you imagined, it might lead to a little bit of a different destination, but it's always the right answer.
Great. Thanks a lot, Laura. So I highly recommend people reading your book and look at, or we're all looking at what Motional will come up with in the next years. And thanks a lot for being my guest.
Thanks so much for having me.
I hope we can continue the conversation at a certain time. Thanks a lot.
Thank you.
Enjoy your day.
You too.